Hello guys, welcome back to the channel. So today we are going to discuss about B trees. So what is this B trees and how do we use them? So I will explain one after other. So basically B trees are given like B trees. So what is the speciality of this particular tree when compared to other trees? And what is the difference from other trees? And what is the kind of variations that we have while performing insertions, deletions, and search operations? We will discuss in brief. Not in brief, in detail. Right. So, this is one note, guys. So, mostly ఇక మీద నుంచి ఇందులోనే క్లాసెస్ చెప్పొచ్చు నేను. So, be ready with this. So, first, B tree. So, we are going to learn about B tree. So, how does B tree look? See, basically, the first foremost point you need to learn is it is a balancing, uh, yeah, it is a balancing search tree. So, that was known for us. So, it is a balancing search tree. But the variation is here in balancing search tree, we can have more than two childs or more than two children. So that is the first variation when compared to normal BST. And the second variation is that this is a height balanced BST, or we can also call as height balancing BST. Height balancing BST. Okay, that is one kind of answer, and this is the other kind of difference what we have. Third difference, do we have anything, or do we call this as anything? Yes, we can call this as M ordered BST. So this single BST has these three kinds of expressions. The way we can express a BST is different. So this B tree basically has this ability of being called as first the balancing, the balancing search tree, then the height balancing BST and the M-ordered BST. So three are applicable to this binary tree. So we have some kind of properties to be discussed. So we'll discuss them in a while. So we come to here and yeah. So now let us discuss the properties of the binary search tree. So what are the properties? The props. What are the props? We have all leaf nodes must have same level. That is the first one. All leaf nodes must have the same level. Yeah. And what is the next one we have? All nodes except root nodes must have at least m by 2 seal of m by 2 minus 1 keys and maximum of m minus 1 keys. See, I have a plan. Instead of remembering these as points, we can make a table out of it. So the table goes like this, where we have uh, maximum, minimum, and here we can have the children. So that is childs, and here it is keys. So this is the way. Let us not try to draw any lines. So this is m. Maximum number of children is m. What is m, guys? Here m is order of BST. Order of BST not, it is B tree. Yeah. order of the B tree. Okay, and this is for childs, maximum number of childs or children, whatever. So it is m, maximum number of children that a node can have. So minimum number of children we have partitions, guys. Here we can have simply going with we can go with leaf. Like for leaf, it is separate. Leaf minimum is 0. We need not to have any child for leaf nodes. But for root, RT is the root. Let us, I mean, I represent root as RT. So in RT, minimum two child should exist, and comma for internal nodes. For internal nodes, it goes ceiling of m by 2. Let me erase this. So it goes like ceiling of m by 2 minus 1. No, no, not minus. Why? Why not minus 1? Because maximum childs, if you take minus 1, how many childs you will keep for remaining keys? How many keys will you arrange? You can't decrease the number of keys. You can't increase the number of keys. You should fit exactly. So that's why we keep it as m by 2 only. Here, minimum number of keys a node should have is m minus 1. Means, for suppose, we have a node like this. So, if m is 3, minimum number of keys means data values like 1, 2. Minimum number it is this. Maximum 3. అంతకు మించి వెళ్తుందా వెళ్ళదు. సో బీ ట్రీలో ఉన్న that particular thing, what, where we can have more than two children. So this is nothing but more than two children. Okay, so next here m minus 1. Now for the root, what we can give? So I will go with rt. What for rt? Minimum number of keys is 1. అంటే if this particular value is the root, like taking this as a root, minimum one key should exist. Okay, so what can we do? If m is 2 means we can push 2 as up, so that is a different case. But minimum one element should exist as a child, sorry, as a key. So if we erase 2 comma 3, at least one should exist. So that is the rule we have. So now this is not required. So as you all understood. So now, yes. Now again, all the remaining nodes, coming to all remaining nodes, what do we do is, guys, now we go with m by 2 seal minus 1. Yes, here we decrease one value for the keys. So minimum number of keys for all the possible nodes is seal of m by 2 minus 1. So just bluntly trust this and follow this table. So this will be useful for you and helpful for you. Now coming to B trees. Now we are going to have a note. What is the note, bro? I am writing, bro. Don't worry. What is the note is uh, basically we need to keep an eye on minimum values only when performing deletions. So what we need to do? Keep an eye on minimum values. Why only minimum values? But why only while performing insertion, while performing only deletions? Because whenever these properties are violated, then this is not considered to be a B tree. So that's why while insertions obviously we will adjust, but while deletions also these get violated. If we leave like that, we can't do anything that was not a BST. So in such situations, what we need to do is we will need to always have an eye on the minimum value. Minimum value. We need to always have an eye on the minimum value only when performing what are the things I have told earlier? Deletions. Okay, that is the one note I wanted to give you. Next, now how do we go with the insertions? So insertions. Now how the thing happens? So let us try it for inserting 1 to 15 elements. Let us try for inserting 1 to, yeah, 15 elements is best, right? So what do we do? First, initially take as 1. So initially, we can take it as m equals to 2. Huh? M equals to 2 is not a good thing, I think so. M equals to 3 is good. And what are the elements? Elements elements from 1 to 15. కొంచెం కొంచెం మంచిగా రాద్దాం. Yeah. Elements from 1 to 15. Yes, this is visible. అర్థమవుతాను. మళ్ళీ వద్దు కాదు ఇది. Yes. So, now while inserting 1, what is the thing that happens? We have 1. 1. O-N-E 1. Wait, yes, 1. We have 1. We have inserted 1 successfully. Now, again, while inserting 2, what we need to do is we need to take again the same binary tree with 1 and add 2. Always note, guys, have a note. Always the elements sorry, are sorted while insertion. Always the elements are sorted while insertion. This is one of the important things you need to understand. And now, yeah, again we come to 3, the third node. Now where do we insert? We don't have space, na. Order is 3, so maximum number of childs is m. Keys is m minus 1. So we cannot insert here. We cannot insert here as a 3. No, that is a blunder. We cannot insert. Then where do we insert? Where do we insert the 3? See, since keys equals m minus 1. If you do not remember, just come here. You can see maximum key is m minus 1. So that is okay. Now come here. Maximum key is m minus 1. So completed. Now we have 4 to insert. Sorry. 3 was not completed, right? Yeah. So in 3, now how do we insert is we used to take some time. Just think of it. While inserting, we have only the టూ లైక్ అంటే మనం 2 కీస్ మాత్రమే పెట్టగలం. మనం 2 కీస్ కన్నా ఎక్కువ పెట్టలేం. సో, ఇన్ థాట్ సిట్యుయేషన్ వాట్ డు వి డూ నా? మిడిల్ ఎలిమెంట్ ఏది? 2. సో, టేక్ దిస్ మళ్ళీ వెనక్కొచ్చింది ఇది. 1 minute guys. Yeah. సో మిడిల్ ఎలిమెంట్ ఏంటి? 2. సో దిస్ టేక్ దిస్ టు ద మిడిల్ ఎలిమెంట్ టు ది పేరెంట్ లెవెల్. అంటే రూట్ లోకి తీసుకెళ్దాం. Now what happens is 2 becomes a parent. 2కి పక్కన జస్ట్ వెయిట్ ఎ మినిట్. మీకు ఎలా చూపించాలో రిప్రజెంటేషన్ బాగుండాలి కదా! సో 2. Now 3 comes here. 1 comes here. Okay. So now what happened is the middle element, which is 2, it comes to from like middle to this. సో ఇప్పుడు 3 అనేది మనం ఇక్కడ ప్లేస్ చేయబోతున్నాం. సో 1కి 3కి మధ్యలో ఉన్న మిడిల్ ఎలిమెంట్ ఏంటి? 2. సో హియర్ వాట్ డిడ్ వి డూ ఇస్ మిడిల్ ఎలిమెంట్ placed as parent. Middle element is placed as parent. So that is what we had done now. That is what we had done. So next, on inserting 4. On inserting 4. Now it is again a balanced B tree. So no worries. Number of keys, -1. No, we didn't add 2 keys still. But still, maximum we can add here only. So no problem. So it is a balanced binary search tree. Okay. So it is a balanced BST. Done. Now, what do? We take insertion of 4. Where do we insert 4? I will directly write. I am not wanting, I don't want to draw the BST again and again. Beside 3, we will place 4. Directly, as I've told, right? When did I told? Yes. Always the elements are sorted while insertion. So beside 1 we kept 2. Why can't we keep 4 beside 3? We can. So keep it. Next, for the element 5. Now for the element 5, when we are supposed to do, see 5 is greater than root. What is root here actually? 2. 2 is root, right? 2 is the root element. If you observe, 5 is greater than the root element. So what do? Move 5 to the right of the root. Okay, bro. I understood what to do. So now what do I do is, now 2 is existing. Here 3 is existing. Here 4 is existing. Now 5 is wanting to come here. So then 4 needs to go. Then 4 needs to get out. So from here to here. So now what happens is, we will get a new kind of a root where 2 comma 4 is the root and 5 is the value. Then what became to 3? See, 3 is existing between 2 and 4 now. So what happens from here? So better if it is a big diagram, you will easily understand how to draw. So yes, this is 2, this is 4. Here we have 5. Here we have 3. And here we have 1. So now it is again a balanced BST. So now, finally, balanced BST is completed. Now going for the sixth element, element 6. Guys, can't we insert directly beside 5? Yes. So we can directly insert beside 5. So I am directly drawing it 5 comma 6. Now 7. Now for 7, what we need to do? Again, we need to do the same thing what we had done for earlier cases. 5 and 6 are existing here. We are wanting to add 7. So we will place 7 here. Then 6 has to go up. Where? నేను ట్రీ ఫుల్గా గీయలేదు కాబట్టి మీరు కన్ఫ్యూజ్ అయ్యారు. నేను కన్ఫ్యూజ్ చేస్తా, మీరు అవ్వకూడదు. You should never get confused just by words or actions. You should get confused by yourself. That is the dumbest thing ever. Anyways, we have 2 comma 4 as a root. So now we have 5 and 6. Now what do we need is we are wanting to add 7 to here because it is greater than 6 and 5. But if we need to place, we need to change 6. Maximum number of keys any? M minus 1. M is 3, M minus 1, 2. So maximum number of keys is 2. So we can't. But we can. But we can. Place 6 here. So 4 go to 6 place. Then where 4 go? Yes. Gallok to say alaga. So now what happens is we used to go with 4. So 4 will become the new root for the binary tree. 2 will become, sorry, not 2. Yeah. 2 will become its left child. 1 is another left child. Here 3 is right child. ఇప్పుడు we have 6, right? So meanwhile we will have 5. Huh? No, no, no. That will never happen. 6 is where? 6 is here. Huh? I'm trying to confuse you. I'm not confusing. You are brightest person. So now we have 7 here. Successfully we placed 7. Now let us go with 8. Now for 8, what do we have? See, 4 is less than 6 is less than 7 is less than 8. If you observe carefully, we can directly place, no? Do, ma. Do along with me. What is there in that? 7, comma 8. Khatam. Bye bye. 8 bro, bye చెప్పు sir. Bye bye. Now 9. What do we do? We have 8 here na. Actually 8 is here. So my suggestion, imagine. Oh, sorry. ఏంటి ఎలా అవుతుంది? I have a plan. Oh, yes. Imagine this 8 is here like this. Imagine 8 is here. ఇప్పుడు 8 ఇక్కడ ఉందంటే 8 ఇక్కడికి వెళ్ళాలి కదా! అదే నెక్స్ట్ జరిగేది. అంతకు మించి ఏమీ లేదు. సో వాట్ హ్యాపెన్స్ ఇస్ బూతులు మాట్లాడకు నాగార్జున. వెనక్కి రా. అసలే మనం సైమన్ క్యారెక్టర్‌లో ఉన్నాం. మనం దేవాలోకి మారాలి. సో ఏం చేస్తాం? వి విల్ చేంజ్. ఓహ్! గైస్ వెయిట్. ఎరుపు కావాలి. వదిలే. So now 6 and 8. Now the 9 becomes the new right child. సాయిరామ్ కొంచెం మంచిగా గీనన్నా. అదిదా మాస్. ఎస్ మిగిలినంతా సేమ్. మరి 7 ఆడకొచ్చిద్ది. 7 will lie between 6 and 8. Now done. Now let us go with 10th element. What is the next element we have in the list, guys? That is 10. So 10. What is 10 here? When we are trying to insert 10, where can we insert directly here? సో ఆ 10ని తీసుకొచ్చి ఇలా తీసుకొచ్చి ఇయ్యాలమ్మా ఇయ్యాల ఎత్తుకుపోతావు ఇయ్యాలంటే అటు వస్తుంది. నెక్స్ట్ 11th ఎలిమెంట్. నౌ we require full graph. Sorry, not graph, full tree. Full tree is required. So 4 root. Okay. సో కొంచెం జాగ్రత్తగా గీయాలి ఇప్పుడు. బికాస్ we might get stepping on the cow dung. So be careful. సో ఇది 6, ఇది 8, ఇది 9, ఇది 10. 7 exists between 6 and 8. 5 exists between 4 and 6. So that's why 5 is here. And here we have 2. Here we have 3. Here we have 1. Done. కొంచెం పర్ఫెక్ట్గా గీస్తే పోయేదేం లేదు కదా. Yes, done. Now this is the binary tree that we have. So గైస్ బైనరీ ట్రీ కాన్సెప్ట్ అర్థం కావాలంటే మీకు కొన్ని బూతులు వచ్చి ఉండాలి. ఫస్ట్ బూత్ ఎప్పుడు కూడా కావాలనుకున్నప్పుడు ఉన్నవాడిని పైకి పంపించాలి. సో ఇప్పుడు మనం ఏం చేస్తామంటే వీఆర్ వాంటింగ్ టు ప్లేస్ 11 హియర్. కెన్ వి ప్లేస్? నో. సో వాట్ డు వి డూ? వి పుష్ 10 టు హియర్. వి పుష్ 8 టు హియర్. అంతే. అంతే. సరే. ఇఫ్ యూ హ్యావ్ డౌట్స్, ఇఫ్ యూ డూ హ్యావ్ ఎనీ డౌట్స్, I will show you something called B-tree visualization. University of San Francisco website ఒకటి ఉంటుందండి. Minimum degree is 3. So insert 1, you will get. Next insert 2. Next insert 3. Next insert 4. మీకు కనిపించట్లేదు కదా? Just a minute. Not window capture. Just a minute. Just a minute. ఎందుకంత కంగారు? నేను చూపిస్తా. I will show you the hell. B-tree visualization. This is known as B-tree visualization. Now what do I do now? You can see, right? So next 5. సో అది అలా వస్తుంది అనమాట. నెక్స్ట్ 6, దాని తర్వాత 7, దాని తర్వాత 8, దాని తర్వాత 9, దాని తర్వాత 10. ఇప్పుడు మనం ఎక్కించబోతున్న బూత్ ఏంటి? 11. సో 11 దోసినప్పుడు ఏం రావాలా? ఇది ఇలా పైకి వచ్చింది, ఇది ఇలా పైకి వస్తుంది. అదే నేను చెప్పింది. So that is what I had told you. So that is what I had told you guys. So what happens now? The 8, what is existing here, it comes here. So finally here 8 exists. So 4 is, sorry guys, concern. Hand ఇచ్చేలా ఉంది నాకు. Yes. So this is 4. This is 8. So insertion of the 11th element is completed. Now we are at the insertion of the 12th element. 12th element, if we need to insert 12th element means now 11 is here. So you can see 11 comes here. So 12. 12 కావాలి అన్నప్పుడు initially we will change this now. So now what happens? We used to go with approach where when we are inserting 12, what happens directly beside 11, it can be inserted, right? ఎందుకు? I will tell you how. I will tell you how. ఇప్పుడు రెడ్ కలర్ ఎరుపు కావాలి. సో ఇప్పుడు మనకి 6 and 10 ఉన్నాయి. నా 7, 8 ఇక్కడే ఉంటాయి. మన 9 ఎక్కడ ఉంటది? సో మనం ఇక్కడ 6 కాదు ఉన్నది. ఏమున్నప్పుడు? ఏముంది ఆ టైంలో మనకి ఏముంది ఇక్కడ? 6 ఈజ్ బిట్వీన్ 4 అండ్ దిస్. సో 4 and 8 మధ్యలో 6 ఉంటది. 4కి 8కి మధ్యలో we will have 6. So now finally what do we have here? 10 is the one what we have. సో ఇక్కడ మనం అరేంజ్ చేయాల్సింది ఏమైనా ఉంది అంటే I will erase these things and rewrite it as, what is the thing we have here? 10. సో 10కి లెఫ్ట్ లో ఏముందండి? 9. 10కి రైట్ లో ఏముందండి? 11. What are you going to insert? 12. Khatam. Bye bye. Goodbye. Gaya. Now We go with 13. 13. What do we do? 12. 12 నుంచి పైకి తన్ను. 12ని పైకి తన్ను. 12ని పైకి తన్నితే ఏమవుతుందంటీ? సామాన్లు సామాన్లు కదిలిపోతాయి. తన్ను దీన్ని పైకి లాగు. On inserting 12, what happens is దీనికి పప్ప అని వస్తుంది సౌండ్. సో ఇప్పుడు ఇది ఏమవ్వాలి? 12 పైకి రావాలి. సో 10, 12 మధ్యలో 11. ఇటు you will get 13 as well as 14. 9 ఏది? 9 ఇటు ఉంటది. 9 will be existing here. గ్రహాంతర వాయిస్ లాగా అక్కడ ఏడుస్తూ ఉంటుంది అది. సో ఇప్పుడు 13 ఇన్సైడ్ చేయాలి కదా, 13 ఇన్సైడ్ చేసేసాం. సో 12 పైకి వచ్చింది అనుకున్నాం. ఎస్, దట్ ఈస్ గుడ్, is correct. Now 14 also we are inserting. 14 will be inserted here. ఇప్పుడు ఇప్పుడు లాస్ట్ బట్ నాట్ లీస్ట్ దోల్ థియరిఫైయింగ్ 13, 14 రెండు అయిపోయాయి కదా. 13 plus 14 both are completed. So now what are we doing? We are going with the 15th element. With the 15th element we are trying to go. So here again I is supposed to draw the entire graph, entire tree. So what are in the root positions? 4 and 8. 4 and 8. What are towards their left? That is the 10 and 12. Towards the right we have 13 and 14. In the middle we have 11. Towards the left we have 9. And here we have 6. To the right child we have 7. To the left child we have 5. To this left child it is 2. This 2's right child is 3. And 2's left child is 1. కొంచెం గజిబిజిగా ఉండొచ్చు. ఐఎమ్ నాట్ సో పర్ఫెక్ట్. ఇది నా ఫస్ట్ వీడియో. సో ప్లీజ్ కొంచెం అడ్జస్ట్ అవ్వండి. కొంచెం అర్థం చేసుకోవడానికి ప్రయత్నించండి. సో ఐ విల్ ట్రై టు డూ మై లెవెల్ బెస్ట్ ఇన్ సచ్ కైండ్ ఆఫ్ video lectures. So now what are we trying to do? We are trying to insert 15 here. Then one Bhutu occurs. So this goes to here. This goes to here. When this goes to the root node. So finally, what happens on inserting 15 is 8 becomes the root. 8 becomes the root. అంతేనా? సో ఫైనల్లీ కథ కంచికి వచ్చింది. సో 8 రూట్ చేసాము. 8 రూట్ అయింది. ఓ మై గాడ్. యా. సో 8 రూట్ అయింది. సో 8 రైట్ లో ఏముంటుంది? 12. 8 లెఫ్ట్ లో ఏముంటుందండి? 4. 4. 8 రైట్ లో ఏముంటుంది? 12. ఇది ఇక్కడికి వస్తుంది కాబట్టి 8 లెఫ్ట్ లో ఇది. సో ఇప్పుడు 12 లెఫ్ట్ లో ఏముంటుంది మనకి? 10, 11. 12 రైట్ లో ఏముంటదండి మనకి? 13 పైకి వచ్చేస్తుందిగా. అంతే కదా. 13 పైకి వస్తుందా, 14 పైకి వస్తుందా మాట చెప్పు. 12. Now what is the thing we have? We can have 14, right? So what happens is we will have 12 అయిపోయింది కాబట్టి we will have 14. కన్ఫ్యూజ్ అవ్వకండి. సింపులే. సేమ్ కైండ్ ఆఫ్ లాజిక్ we are trying to use. సో ఇక్కడ we get 13 and here we get 15. Yes, okay. So can you correct me? I have done a mistake here. The mistake is taking 11 here. So what do I do now? I used to get an eraser and rub this. Ah, so 10 అలాగే ఉంటదండి. What is the thing that we get? 9 and here what do we get? 11. సో ఇది అయిపోయింది. ఇప్పుడు 8, 12 మధ్యలో ఒకటి ఉందన్న అదేంటది 6. 6ఆ? కాదు. 6 4కి వచ్చేస్తుంది. 4 రైట్ సైడ్ అయిపోద్ది. సో we can't even go with the 6 blindly. So 6 is different, guys. So here only B tree will play kabaddi with you. Ah, if you are bluntly trusting na, it will keep pedda palakova in your mouth. Be careful, okay? And oh my god, నేను notes లో ఇలాగే ఫాస్ట్ గా రాస్తాను సార్ అలా చెప్తారు కాబట్టి. But still, this is 5. Ah, here we will know 2. Here it is 1. And here it is 3. If you observe 1, 3, 5, 7, 9, 11, 13, 15, all are at same level. All are at same level. Again, 2, 6, 10, 14, all are at same level. Next, 4, 12. All these two are at same level. And finally, 8 is nothing but Supreme Yaskin. So it will add. Okay. So if this guy is Yaskin, he is Commander Manas. This is Bhairava. This is Bujji. వద్దులే కొంచెం మరి కొంచెం సినిమాటిక్ వెళ్తున్నాం. Yes. So this is how do we perform insertions in binary search tree, which is a balanced binary search tree named as B tree. Okay. So this is session 1 on B trees, guys. సో ఇది ఇన్సర్షన్స్ మాత్రమే కొంచెం స్లోగా కాదు కొంచెం చాలా స్లోగా వెళ్ళాను బట్ స్టిల్ మీకు అర్థం కావాలి కాబట్టి యాజ్ యూ నీడ్ టు అండర్స్టాండ్ వాట్ ఈస్ వాట్ I went somehow slow. So that's why ensure ఇన్సర్షన్ కి కొన్ని స్టెప్స్ ఉన్నాయి అవి చెప్పేసి వీడియో క్లోజ్ చేసేద్దాం సో I would like to write them down directly. So what are the steps of insertion? So we will try to go with the steps of insertion. So insertion steps in the sense what do we have? Check if the tree is empty. So this is first insertion step. Then, if tree is not empty, find suitable leaf node to which new key value is added using BST logic. Next, if leaf node has empty position and then add new key to the leaf node in ascending or sorted order within the node. This is what I had told you here. This one. Next. ఇది అక్కర్లేదు సారీ ఎస్ you might be asking bro can we have yeah సో ఒక్కొక్కదానికి ఒక పాయింట్ కింద ఐడెంటిఫికేషన్ కోసం ఐ విల్ చేంజ్ ద కలర్స్ డోంట్ వరీ సో దీనికి ఐ వుడ్ లైక్ టు బ్లూ సో ద నెక్స్ట్ పాయింట్ is if the leaf is full, split the leaf by sending the middle key value to its parent position. Repeat the same until the BST is balanced. Not BST until the tree is balanced. So here, not likely to go with this. So I would like to change the color. మరీ రెడ్ వద్దు బ్రో. కొంచెం డార్క్ ఉంది కనిపించదేమో. ఆరెంజ్. Okay. So these are the insertion steps that we follow. Okay. So these are the insertion steps that we follow. And ఇది ఇంత కిందకి వచ్చే బదులు నేను కొంచెం జాగ్రత్తగా పెడతాను. ఇది లైక్ ఇట్ వుడ్ బి ఓవర్ హియర్ and this would be over here and these things let me take up to 5. So కొంచెం కిందకి. Now from 6 onwards up to 10 I would like to place them here కొంచెం పక్కన. And from 11 obviously we would like to go with the side of uh, this. So here we can go with 11. మనం కొంచెం చిన్నది చేయొచ్చు. Not at all an issue for this. We can make it small. మీకు అర్థం కావాలంతే, as long as you can understand, no issues, guys. So this is the session 1. So if you have any doubts, please don't try to not being asked, not to ask them. Please ask doubts. See, without asking doubts, you can never learn anything. Ensure that you ask doubts whenever you have. Okay? So that's it for today, guys. Thanks for watching. Bye bye. కొంచెం ఓపిక్గా విన్నారు. I can know if you see up to here, you will come to a clarity. Okay, కొంచెం ఓపిక్గా చెప్పాడు ఇవాళ అని. Thank you. Bye bye.